This question has a curve, a graph on it, and it's saying use the graph of the function above to estimate the value of f prime of 0 to one decimal place. It says it'll be a whole number or end with zero point 0.5. So here's 0. So here's the point at 0. And they want us to estimate f prime of 0. So what does that mean? F prime. This is called prime, this little mark. It's a little single quote mark, prime, and it means the slope or derivative at x equals 0. So it means the steepness. How steep is it? So it's like if you're riding on a roller coaster, you could be riding on a roller coaster. Oops, that's terrible. Let me try that again. Suppose you're riding on a roller coaster and you're in this part, you're going up, it's real steep up. And if you come over at the very top of the roller coaster, you're flat and then keep going, you're right here. So what's your steepness right here? If you're headed down there, right? What's the steepness right there, right then? Well, they want us to estimate it. And so I think it looks like it goes from here to about there. Is that good? Let me change it because I can see it better. From here to about there, I think. Yeah. It looks to me like it's going down one over a half. Because slope, we're doing slope, right? It's rise over run. Slope is rise over run. So it looks like it's down one, right 0.5, like half. So it only goes half a unit. Maybe I made that too big. See right here? There, about half a unit over, down one. So the rise is down one over a half. If you divide that in your calculator, you'll get -2, which is indeed the answer. So I go right here and I just estimate the steepness, the slope right there. And it looks like it's going down one. Slope is rise over run. So I draw a little line that's the steepness of the curve right there. Looks like it's down one over a half. Divide that, that's -2. Or if you want, another way you could see that perhaps more clearly is if you just extended this line. Let me show you. You just let this go all the way down to there. Yeah, that might be a more clear way to see it. So it's more clearly down to, or you that'll work too. Oops, that didn't look so good, did it? Just kind of did it again. I don't know. So this is now you can see, well, this is down two, right one. Same answer, right? The slope is down two over one. That's still -2. Either way you want to calculate it. That's the thing about slope. It just keeps going in that direction. Right? I could just go further and it go down 4/2, or just go further down 8/4. It's just going to keep coming out -2 because that is the steepness. Doesn't matter how far you go. That's the steepness of this line. Take it as far as you want down over, further, whatever, -8/4 is still going to come out -2, right? That's the steepness of the line, however you want to do it. You just find the steepness and you go as far as you want, just go to something convenient, rise over run, and you get the steepness of the line, of the curve, of the line tangent to the curve, right at that point. The steepness of the curve, that really is right at that point, which is something very important in engineering and all kinds of science, is to calculate the slope at a point. And then we call that the derivative and we notate it with a prime.